expected goals.
So these are results we collected from the data, and we split them into our 8 zones initially, and then we tallied up the number of shots, the number of goals that resulted from these shots, then the StatsBomb XG, which is calculated as each shot in the StatsBomb data. StatsBomb give their own value for an XG, which takes into account many more variables than we did, such as whether the shot was a volley, a header, how far away the player was, as well as where the goalkeeper was. So we summed up all of the StatsBomb XG values for the shots and divided by the number of shots to find the mean StatsBomb XG. And then our XG was calculated by dividing the number of goals in each zone by the number of shots. So from our results, we're able to tell that shots taken closer to the goal are more likely to result in one. So a good example of this would be in zone 1, the 6-yard box. Our XG calculates that to be 0.306, or about 30.6% chance of a shot from the 6-yard box resulting in a goal. If we were to compare this to, say, zone 7, the midfield centre, there's a 0.0199, or around a 2% chance of a shot from that zone resulting in a goal, showing that shots closer to the goal are more likely to result in a goal. Our results are also able to show us that shots towards the centre of the pitch are also have a higher chance of resulting in goals. So a good example for this would be zone 3, the inner penalty spot, has a RXG calculates that to be 0.2214, or about 22% chance of going in. If we compare this to zone 5, the attacking wings, this has a 0.1278, or about 12% chance of a shot from that zone resulting in a goal. So it's beneficial for the player to be shooting from near the centre of the goal. The results can also tell us that our model is quite simplistic, and there are differences between our results and the ones found in the StatsBomb XG. So this leads me on to, if we were to redo the project, there are some improvements we would like to make to our model to try and reduce the gap between our results and the results that were found by the StatsBomb XG. So one way we thought about doing this would be to make the zones smaller. So currently, the zones are relatively large, which means that 2 shots which are quite similar positions, but are taken from different boundaries of different zones, they'll be given different XG values, when in reality, they will actually have very similar values. And conversely, 2 shots that are taken within the same zone, but at opposite corners of the zone, will be given given the same XG values, when in reality, there is a different probability of each shot going in. So another weakness in our model was that we only considered one variable, which was the location of the shot on the field, when the number of defenders between the player and the goal, where the goalkeeper is positioned, and whether the shot was a header, a volley, or off of the chest save, these all affect the probability of that shot resulting in a goal. So if we were to redo this, we would try to include more variables, which would increase the validity of our results. But the main reason we believe there were discrepancies between our data and the ones found in StatsBomb's XG was due to our relatively small data size. So within the free StatsBomb data, there were 1,106 matches. So this led to, say, in zone 5, there only being 133 shots and 17 goals, which means that one shot can have quite a large impact on the probability on our XG. But this can quite clearly be seen with StatsBomb XG coming out at only 0.06 compared to our one of 0.1278. So the main improvement we would like to make if we were to redo this project would be to find data sets with more gains to decrease the effect anomalies would have on our results. So now I'm going to hand over to Sid, who's going to talk about his prediction model.